Okay, everyone. I am going to do a very short video on a homework question that I was asked about in one of the Zoom student hours. Homework 2.2, number 7. It seems like it's kind of a difficult question, and absolutely there's a lot of stuff there. This is talking about solving these matrices using the Gauss-Jordan elimination method. So one thing to remember and think about for all these matrices is that these matrices are not just things by themselves. They come from a really specific place. And that place is that each of these rows represent an equation, right? Uh, this column here represents the x variable coefficients. This one, the y variable, here the z. And these, the constants, what's on the other side of the equation. Now, if you've dealt with matrices before, you'll know this is actually kind of an abbreviated version of matrices, and we're not dealing with the variable vector and all this other gosh, whatever. We're really focused on the fact that this is an augmented matrix representing this set of equations. For Gauss-Jordan, the goal for us is to try to get everything to look like this. We want some kind of what we call a diagonalization of this matrix where we have ones on the diagonal and zeros here pretty much everywhere else except for this spot, and this spot. Well, why? Again, it comes back to the fact that each of these little rows represents an equation. Here we have x is equal to some number, 1y is equal to some number, and 1z is equal to some number, whatever they may be on this side. So that's great. That would tell us exactly what the solution is to the very initial system here. Now, for three variables, this elimination method is really difficult sometimes just because there's three of these things and it's really confusing to make sure everything is accounted for. You have all these variables, you have everything written out. We use matrices for exactly these kind of more complicated situations to represent, something really complicated in a really simple way. What that means is that, the operations we use here have to be reflected somehow in the fact that each of these rows represents an equation. So what do we mean by this? Well, the very first step in kind of getting this matrix to look like this one over here is this very top left element. We want that to be a 1. And if we want this to be a 1, that's the same idea as making this 6 a 1. Well, how can I make this whole kind of row, this whole equation, right? What do I multiply this by so that this becomes a 1? Well, we multiply by 1/6. And I know this kind of notation here, 1/6 row 1 is the new row 1, can be a little difficult to understand, and it's also easy to confuse with equations. This is not an equation. These are equations. Do not use arrows for anything other than just saying, hey, I'm replacing this kind of row operation with this next row. And this idea of row operations, again, is for matrices, and it's all based on the fact that each row represents an equation. So getting into this a bit more, 1/6 row 1 is the new row 1. The way we do this is we literally just think about, well, what's this number times 1/6? Now, all of these are kind of nice numbers to multiply by 1/6 because, 6 times 1/6 is 1, -6 times 1/6 is -1, 102 times 100 by 1/6 is 17. So if you need a little bit of like mental math to do that, heck, I even had to do a little long division over here. That's fine. Do that. For a lot of these small computations, you don't need your calculator all the time. You really can just do a little bit of mental math and just remember how do we kind of compute these values. So what does that do for us? Well, that kind of reduced or changed this row into this kind of nicer form where we have a 1 here, and that's kind of the first step in these kind of Gauss-Jordan elimination questions. The second and third steps are usually getting these things to be zeros, and they already are, so we don't have to worry about that for the moment. The next step generally is to make this middle entry a 1, and again, we do the same thing by saying 1/4 row 2 is the new row 2. Remember, you have to multiply 1/4 by everything in this row, including the 0, but that's just 0. 1/4 times 4, by design, right? We are forcing it to be a 1. And then 1/4 times -3, -3/4, and again, -3/4. I know fractions are not our friends all the time, but we really should write these things in this fraction form. We'll see why in just a few minutes. So here we had all these extra zeros, and that made it kind of easy, but now we don't have a 0, right? This is a 7. We somehow have to eliminate this. Remember, this is elimination somehow. So I want to eliminate this variable, and to do that, I'm going to use this one. I'm going to use this one to eliminate the 7 by saying, hey, what do I multiply 1 by so that when I add it to 7, I get 0? In other words, what do I multiply 1 by to get -7? Well, -7. And so this next row, this next kind of row operation, I should say, kind of shows us what that step looks like. Row 3 plus -7 row 2 is the new row 3. I know this row notation looks a little funny, and for these 3x3 systems, maybe do we need it all the time? That's a good question. In week 3 of this course, we will have a whole new set of questions and a whole new content area that requires row notation. We literally can't do it without this row notation in solving things called tableaus, and we'll talk more about that later. Okay, so what does it look like to actually do this computation, right? Row 3 plus -7 row 2 is the new row 3. So the way I kind of look at it is -7 times this number plus this number is this new row 3. Notice row 1 and row 2 are all the same, right? No changes here. So then I look at the next entry. -7 times 1 is -7, plus 7 is 0. And again, this is by design. You could do a whole bunch of stuff, but we're trying to get a specific goal. So anything that doesn't help us get to our goal, probably not going to do. -7 times -3/4. So what? That's going to be something like +21/4. And then we have to add that to -7. So you can see down here, I did a little bit of scratch work. 21/4 minus 7. Well, 7 is also 28/4. And 21/4 minus 28/4 is -7/4. I know, fractions. Really, this is making things really simple. If you do go ahead and try to use your calculator for this, your decimal values will get really strange and really weird pretty quickly. I would recommend just leaving everything in terms of these fractions. Okay, the last thing is I really do need to multiply everything in this row, including the constants. Half of the time when students make a mistake, it's because they forget this last entry here. So -7 times -3/4 is going to be +21/4, and I have to add that to 7. Again, down here, I do a little scratch work. 21/4 plus 7, well, 28/4, so really just the addition of this over here, 49/4. Cool, 49/4. Well, from here, we have this 1 and all these zeros, this 1 and this 0, and now we really want this to be a 1 as well. So what do I multiply -7/4 by to get 1? Take a minute. -4/7, right? The flip of this kind of fraction. And that's really the purpose of including fractions in these matrices. We're always worrying about, what do I multiply this number by to get a 1, or to cancel out with this other thing? Fractions make that really easy. Decimals, not so much. So way over here, we have -4/7 times row 3 is a new row 3. And if you do that, again, row 1 and row 2 all the same. Here we have 1, again, by design, and we get this -7. Remember, this row can be interpreted as an equation, and this just says z is equal to -7. For most of this class, for this week anyway, we will be using x, y, and z. We'll see in situations in week 3 where we use other variables. Okay. So from here, there's actually kind of a branch that we could actually take where we use what's called echelon method. The echelon method is different from the Gauss-Jordan method. Remember Gauss-Jordan, we want to get all of these entries here. Echelon just says, hey, give me all of these diagonals as 1s, and then I can actually solve for this first and use what's called back substitution to solve for y for this one, and then for x by knowing y and z for these from these other two equations. So that's kind of like a side route you can take. But again, we're more interested in the Gauss-Jordan. And so the next step here would be, well, 1, 0, 0, 1, 0, 1. We want this entry to be a 0. So I multiply this row 3 by 3/4, and I add it to row 2 to be the new row 2. Here, did it. Here you can see that when I actually did this, I had to do a little bit of mental math, right? I had to multiply 3/4 by -7, and then add it to -3/4. And I actually just got -6. This happens quite often where we run into fractions, but then pretty quickly we get out of them. But even if we don't, even if these answers are fractions, that's fine, not a big deal. The last two things we have to do is make this a 0 and make this a 0. And this question is set up nicely where now it's just a matter of saying, oh, well, I just add row 3 to row 1 and make that the new row 1. Row 3 plus row 1 is the new row 1. And then I do that again, row 2 plus row 1 is the new row 1. Do remember, don't forget, the constant column, you really have to include that in the back substitution. Or, sorry, you really do have to include that when you add these rows together. The very end, right, 1, 0, 0, this just says x, 1x is equal to 4, 1y is equal to -6, and 1z is equal to -7. Sidebar, is that a lot of work for one question? Yeah, it absolutely is. This material does take quite a bit. There are kind of other things you can do, shortcuts with graphing calculators, with online websites, whatever. I would not recommend that. If you shortchange yourself and don't really learn this row notation, week 3 is not going to be fun. I'm just gonna be honest with you there. When I say not fun, I mean a huge pain. Yeah. So what's like an efficient way, right? There's a lot of stuff going on there. How do I actually like make this into a simple series of steps? And what I would recommend is, because we want this, 1 on the diagonals and 0s everywhere else, I would recommend kind of this order of trying to make these things 1s or 0s using those row operations. First thing first, I would try to make this a 1, this upper left entry a 1. And then I'd use this to eliminate these next two entries, right? This kind of middle one here and this bottom. The next thing is to make this a 1, and then use that to eliminate the bottom one. After that, this should be 0 and 0, and you should have a number here. We can make that a 1 pretty easily by multiplying by its reciprocal. Notice for these are just what they are. The constant values just kind of come out of the fact that we're doing all these other row operations. So now you have 1, 0, 0, 1, 0, and 1. Now we're going to eliminate the other entries by using this one to eliminate this entry here to be a 0, and then this one to be a 0. And then the very last step is to use this one to eliminate this entry here. Okay, a lot of steps I know. Practice. Give yourself some time. Try these things out. And if you have further questions, do let me know. Thanks.